Okay. So this is my Lab 1 for the half adder, full adder, and then the 4-bit incrementer and adder. So first was very simple with the 1-bit half adder. Um, Basically, as the inputs are odd, it'll increase the sum, and if they're even, the sum will be 0. And then if they're both positive, then there will be one carry out, which is shown by the wave. Basically, the XOR gate adds either a 0 or a 1 to the sum, and then the AND gate shows the carry out in the wave. And then the 4-bit incrementer was basically just a step up to increment each sum into a 4-bit pattern. And as the increments went up, I think it was at first difficult to understand this wave, but seeing how you can open up this Y component and seeing how the carryout moves up the circuit, it made it a lot easier to understand how this looks a lot just like a normal counting in binary. Um, the 1-bit full adder took me a while to understand how, similar to the last one, the odd number of inputs gave you a sum of either 0 or 1 for that 1 bit, and how all three components came out to give you a carryout. And it took a while to understand how that all worked together as I was trying to build the 4-bit adder. But after some experimenting and lots of help with understanding how all of the pieces work together, similar with the output moving up and adding A and B to get a Y value, which was just binary addition with two 4-bit values to produce hex. So I guess adding hex values, and this kind of converts it to a binary form and an output with your X. And then based on how the carryouts and each individual piece added together, the circuit will bring out your carryout if there is that carryout in the addition, or an overflow if your signs switch or if that addition creates an overflow. And I did a couple of different tests basically to check each different scenario to make sure the circuit actually worked. First with the stuck at 1 faults and the stuck at 0 faults, which both passed, kind of showing that the circuit should work and everything should be connected correctly. And then just with various different simple experiments, seeing how the carry in will increase your output by 1, because that carry in from the last output or kind of hypothetical output carries into the next one to add 1 to your overall value. And then um, this was just small addition to show how positive numbers add to positive numbers when they're small enough and there's no overflow or carryout. Um, then how adding 1 with a carry in can bring that over to an 8, which makes it a negative number, which isn't how it should work. So that will make an overflow. Adding positive and negative numbers, as shown here, will not have a carry, or I mean, it won't have an overflow. And then in another case, a larger positive and negative number will have a carry out, like adding 11 to 6 is greater than your 4 bits and has a carry out. And then two larger negative numbers is an example of how you can have carry out and overflow. And it's kind of small, but each of those individual cases are tested and proven in the GTK wave. Um, So yeah, all of these tests were again kind of run to check each individual possible scenario of that hex or binary addition to test all possible inputs and outputs and all the different ways we can get just a standard addition or the cases of carry out, overflow, or both in both positive and negative. And yeah, that is my lab one.